Alright, we're going to look at section 7.4 today, which is going to talk about an ellipse and ellipses. So an ellipse is, you've probably seen an ellipse. Here's a picture of one here. It's kind of a circle that's elongated in one direction. But the formal definition of ellipse, it's the set of points whose sum distance so we take two distances, we add them together from two given points, and we call those given points focus, or foci is the plural. From two given foci is a constant. We'll explain what that means. So we have all the points who, if you add the distance from two given points, is some number. So if I look at my picture down here, let's say I have 2 points, which we call foci. So this is a focus here, and this is a focus here. So if I take any point on this ellipse, let's say I take this point here. So if I take this distance here, we'll call it D1. And this distance here, we'll call it D2. I can add those two distances together, and I'll get some number, I'll call it K. Now if I take another point on the ellipse, let's say it's over here, and I take this distance, we'll call this L1, and the distance to the other focus, which is way over here, we'll call that L2. Then I know L1 plus L2 also equals this same number K. So no matter what two distances you add from any point on this ellipse to these two these two foci, it is always the same number. We really don't care what this number is, we just will always know it is a constant. Now there's some other kind of neat things about an ellipse, some different parts of the ellipse that we should talk about. So an ellipse is always going to be longer in one direction. So this direction where it's longer, in this case it's this way, it's split by what's called the major axis. So this major axis is how long the ellipse is. Now this thing, the major axis can go up and down. So if we have an ellipse that looks something like this, the major axis goes up and down versus left and right. We have this other axis, which goes this direction, and this is called the minor axis, because it's shorter. We have some points on this ellipse which are pretty important. We have this point and this point on the major axis, which are called vertices, or vertex. We have a vertex on each side. We have inside on the major axis these focus. So we have two focus, two vertex on the major axis. And then on the minor axis we have what are called covertexes. And these are just really the ends of the minor axis. So the biggest things are major axis, minor axis, the vertex, the covertex, and the focus. So our goal is to be able to graph ellipses and also to find equations and kind of convert back and forth between those. Well, just like before, we'll start with ones that are centered right in the origin, and then we'll move to ones that are not centered in the origin. Okay, let's look at our first equation. All the ellipse equations are very similar. They only differ on the numbers in them. This first equation is for an ellipse centered at the origin with the major axis along the x-axis. So this would look like an ellipse where we have the center right in the middle, and then we have an ellipse that's longer in the x direction versus the y direction. So something like this. Okay? So what we know is any ellipse that's centered at the origin that has a major axis along the x-axis is given by this equation. X squared over a squared plus y squared over b squared equals 1. Now some very important things here. We have AB, and in this case A is always bigger than B. The bigger number is always under your major axis. So since the bigger number is under x, it'll be longer going left-right. if the bigger number was under y, which we'll do in the next one, then the ellipse would go up and down. So on this, we have the points. We have our vertex here. We have our vertex here. We have our foci right there. And we have our co-vertices down here. Now, this AB, A is always the distance from the center to the vertex. So in our picture, this distance from the center all the way out to the vertex, this would be A. B is going to be our distance from the center to the co-vertex. So this distance here is B. So those are the things that go into our equation. We have A, which is from center to vertex, B, which is center to co-vertex. Now, this foci, we call this distance C. So the distance from the center to the foci, each focus is C. Now, we don't have that in our equation, but we actually will use it in the following relation. Because this A, B, and C can be related with this equation. So these three distances, center to vertex, center to co-vertex, center to focus, can be related by B squared, I'll write a little bigger over here, equals A squared minus C squared. So the most important thing is to know what these distances are. And then when you're actually dealing with this, you're really just counting from the center to the vertex, or center to co-vertex, or center to wherever it may be. But you're trying to figure out from the equation what these A and B are, and then based on this equation, you can find C. Or if you have any of them, you can find any of the others. So let's give it a try. Let's try to write an equation for an ellipse. I want to find an equation with an ellipse with a focus at -7, 0 and a vertex at 10, 0. So I'm just going to kind of do a rough sketch. So we're still centered at 0, 0. We're starting there. So we have a vertex way out here at 10, 0. So this distance from the center to the vertex is 10. Now if you remember from our values, A, B, and C, A was the distance from the center to the vertex, so in this case this is 10. Now B was the distance from the center to the co-vertex. I don't have any of the co-vertices, so I don't know that. We have one focus over here at -7, 0. So this distance is 7 from the center to the focus. Now center to focus, that was C. Now if I'm writing my ellipse equation, x squared plus y squared equals 1, I want the bigger number to go over the major axis. So I want A to go under the x because it's longer this direction. So I have 10 squared there for A. And now I just got to figure out what B is. I don't know what B is, but I know what A and C are. But if you recall, we have that relation B squared equals A squared minus C squared. So B squared equals 10 squared minus 7 squared. So B squared equals 100 minus 49. So B squared is 51. So if I take the square root of that, B is going to be the square root of 51. So I can put that up there. Now the good news is I really don't need to know what that is because in my equation, it's x squared over A squared, y squared over B squared. So if I write that out, 10 squared is 100. The square root of 51 squared is just 51 equals 1. So again, really everything comes down to figuring out what A, B, and C are, figuring out how far it is from the center to the vertex, center to co-vertex, center to foci, and then just going from there. Okay, now that we've written an equation based on some information of ellipse, let's see how to graph them based on an equation. So we have our equation x squared plus over 25 plus y squared over 8 equals 1. So we know these are still centered at 0, 0. So there's our center. And so the easiest way is to pick out what is A, what is B, and what is C. And we can get A and B from the equation pretty easily, because A squared is the number always the bigger of the two numbers. So in this case, A squared is 25, so A is 5, because 5 times 5 is 25. B, so 8 is B squared. So if B squared equals 8, B is equal to the square root of 8. And because we're going to be graphing this, we're going to know B square root of 8 is about 2.82. That'll be helpful for us. Now C is actually not given in the equation. Remember, the equation only gives us A squared and B squared. It does not give us C. But if I want to find it, we know B squared equals A squared minus C squared. So B squared being 25, and A squared is the square root of 8 squared, which is 8, minus C squared. I did this backwards. B is square root of 8 squared. That makes more sense. So square root of 8 squared is 8, equals 5 squared, which is 25, minus C squared. I'll subtract 25 from both sides. 8 minus 25 is negative 17, equals negative C squared. The negatives will cancel out, so we could take the square root of both sides. So C is the square root of 17. So getting A, B, and C is critical to doing these problems. Once you get A, B, and C, and you know what A, B, and C are, this is actually pretty simple. So now we know the major axis is the x-axis, and the reason I know that again is because the bigger number is under x. We'll do some problems with the bigger numbers under y, and the only difference is the major axis will be on the y. So A is 5. This is the major axis. So the vertices and the focus lie on this. So we go 5 units in this direction. So there's a vertex. 5 units in this direction. There's a vertex. B is square root of 8. So we'll go 2.8 up and down to our co-vertex. So somewhere like there. Co-vertex. Down here to a co-vertex. So these points are really enough to draw my ellipse. You can kind of see the ellipse going around like this. So the focus is square root of 17. Square root of 17 is 4.2-ish. So our focus, let's zoom in on this, our focus are going to be still inside the ellipse, somewhere right around there. So there are my two focus. So we've got our ellipse, we've got our A and B, which really is plenty to graph our ellipse, the A and B, because it tells you how wide and how tall. But then we also can find the focus. Below I graph this on Desmos, and you can see it does basically the same thing. Here are the same vertices at 5 and negative 5. Here's our co-vertices, which we didn't know the exact value, but it's the square root of 8. It doesn't put the focus in there, but we know those are somewhere around here and somewhere around here. So, again, does a really nice job of graphing these. Okay, if you look at this next equation, it's really the same equation as we've been dealing with, the x squared and the y squared, but you notice in this case the a squared is under the y. So what that does, when the bigger number is under the y, it just makes it open along the y-axis. So instead of being longer left and right, it'll be taller up and down, so something like this. So your center is here, your vertices are up and down now, your focus are up and down, and your co-vertices are left and right. So it just flips it to the other direction. Everything else is the same, it's just the smaller number is under x in this case, and the bigger number is in front of y. The same relation holds with A, B, and C. A, B, C still mean the same thing. It's just the vertices are up and down versus left and right. So if you look at this one, graph the following ellipse, x squared over 9 plus y squared over 100 equals 1. So in this case, the bigger number is always a, so this is a squared and this is b squared. But the major axis is the y-axis. It goes up and down. So, a, in this case, a squared is 100, so a would be 10. B squared is 9, so square root of 9 is 3. And c we don't know. Now again, we can find c with that same relation. The same relation, b squared equals a squared minus c squared. So b squared and 3 squared is 9 equals a squared of 100 minus c squared. So if I subtract 100, we get negative 91 equals negative c squared. Negatives will cancel out. So c is the square root of 91. Square root of 91 is 9 point something. We'll say 9.5-ish. So we have our a, b, and c. That's the most important thing. We got a and b right from the equation. So graphing it, we have our center. Now a is the distance from the center to the vertex. But instead of going left and right this time, I'm going to go up and down. So I'm going to go up 10, and I'm going to go down 10. Because the y-axis is our major axis in this case, because the bigger number was under y squared. My co-vertices are 3 away, so here and here. So you have a really, really skinny vertical ellipse in this case. The foci, 9.5 away, those are always on the major axis, so those are out here as well. So again, knowing what a, b, and c are, knowing the bigger numbers under your major axis, really all there is to this. So if we look at the bottom one here, here is our ellipse graphed on Desmos. Looks the exact same. Here is our 10, our negative 10. Here is our 3 and our negative 3. And it's obviously taller going up and down versus left and right. Okay, here's another ellipse, 20x squared plus 10y squared equal 20. Now this doesn't look like our other ones, because if you remember the other ones, it always equaled 1. So what we want to do is we want to try to put it in the correct form. So ellipses always need to equal 1. So we need a 1 on this side. So what I'll do is I'm going to divide everything by 20. So 20 over 20 is 1. So I can write this as x squared or x squared over 1. 10 over 20 reduces to 1/2, so this is y squared over 2 equals 1. So what this tells us now is here is my a squared, and here is my b squared, because remember a squared is always larger. So the major axis is going to be the y-axis, because the bigger number is again under the y. A is going to be the square root of 2, because a squared is 2, so if I take the square root of that, I get square root of 2. B is going to be 1, and C, I don't know. So, if I want to find C, I'll go back to the same equation we've used for all these, which says b squared equals a squared minus c squared. So b squared is 1. The square root of 2 squared is 2. Minus c squared. So I'll subtract 2, so we get negative 1 equals negative c squared. Cancel the negative, take the square root, so c is 1. So this equation, this little b squared minus equals a squared minus c squared, very important for ellipses. So now we have our a, b, and c, so I can start graphing my ellipse. So the center is still at the origin. No shifting's happened yet. The A is square root of 2. Square root of 2 is about 1.41. So when I'm doing this, I'm going up and down because the major axis is in that direction. So I'm going to really zoom in on here, because 1.41 would be like there and there. So this vertex would be 0 square root of 2. And this one down here would be 0 negative square root of 2, because I go up and down square root of 2. Now B and C, if we recall, were 1. So my co-vertices would be 1 in each direction this way, so 1 there and 1 there. So there is my little teeny ellipse. This is a small one. The foci would be on the same axis as the vertices, so they would be there and there, 1 unit away. So my foci, if I wanted to write their coordinates, would be 0, 1, and down here the focus would be 0, -1. But again, it's really all just based on the distance, A, B, and C, from a given center point. I also graphed this one on Desmos, and I didn't even put it in the standard form. I just typed it in. You can see I just typed it in exactly how the problem was originally started. And here's my ellipse. So here's my 1 and -1 for my co-vertices. And here's this number between 1 and 2, which we know is square root of 2 here and negative square root of 2 here. Okay, so now the only thing we really have left to do is talk about what if our ellipse is not centered at at 0, 0. What if it's centered at some h and k? Well, very similar to circles, we will just shift it by the h and k by subtracting h and subtracting k from our equation. So if we look here, find the equation of ellipse with a center of -3 and 1. So that's there. So the center is -3, 1. And a vertex at -3, 3. So there is a vertex there. And a focus at -3, 0. So there's a focus here. So when I write my equation, right away I can start with I know the center is -3, 1. So instead of just x and y like we traditionally have here, just like in the circle and in the parabola, we take the opposite of that. So the opposite of -3 would be +3. The opposite of 1 would be -1. So we've got our top, so they're x plus 3 and our y minus 1. Now we have to figure out is what is a and what is b. Because if you remember, down here is a squared and down here is b squared. So we just have to figure out what those are. Now a is the distance from the center to the vertex. So if you look here, center to the vertex here is 2 units, so a is 2. So I will put a as being 2, but now I don't actually put it under the x. So this is actually going to be b squared and this is going to be a squared because I want the bigger number under the major axis, and the major axis is going up and down. So I'm going to have to put the a squared, which will be 2 squared, under the y term. And that's simply because all the good stuff is going on up and down. It's going vertically. So our ellipse will eventually look something like this. But I know wherever axis the focus and the vertices are on, that's our major axis. So now I have to find b, which is be the center to the co-vertex, which I don't know. But I do know c, because from -3, 1 to -3, 0 is 1 unit. So I know c is 1. So our b squared equals a squared minus c squared. So b squared is going to equal 4 minus 1. So b squared is going to equal 3. B is going to equal the square root of 3, but since we want b squared under here, it's actually 3, because if you square the square root of 3, you're back to 3. So there's our equation. So same thing, I was just counting spaces, center to vertex, center to focus, using my relation, and then the only thing different is when we put these things up top. Okay, let's look at our last ellipse. So we want to find the center endpoint of the major axis, foci of the ellipse below, sketch the picture of the graph. So basically graph the ellipse. So first I'll start with the center. Now this one has a different center than 0, 0 because you can see it has the -2 here and the +3 here. So just like a circle, we just take the opposite of that for the center. So this would be 2 and -3. So this ellipse will start at 2, -3, which is here. Now the major axis, which of course is the axis that is longer, is going to be whatever number is bigger, which is 25 is bigger than 16. So the major axis is the y-axis. That means the ellipse will go up and down in some direction. So now all we have to find is our A, B, and C, and that will help us plot the rest of the points for our ellipse. So since the bigger number is 25, A is the square root of 25, which is 5. B is the square root of the smaller number, so that would be square root of 16, which is 4. C we do not know, but if you remember the relation B squared equals A squared minus C squared, we can say 16, because 4 squared is 16, equals 25 minus C squared. Subtract 25 from both sides, you get negative 9 equal negative C squared. I can turn both of those negatives positive just by dividing. So C is going to be the square root of 9, which is 3. So A, remember, is the distance from the center to the vertex. So I go up and down 5 from my center. 1, 2, 3, 4, 5. So there's a vertex. 1, 2, 3, 4, 5 down. There's a vertex. So if I wanted the order pairs of those vertex, well, that would simply be 2, 2. And that would be 2, negative 8. And that's, again, just counting boxes. B, which is the covertices, are 4 over from the center. So 1, 2, 3, 4 there. 1, 2, 3, 4 there. Those are covertices. This problem doesn't necessarily ask for these, but those are important to help us graph our ellipse. Looks something like this. C is the distance from the center to the foci, so I could go 1, 2, 3. And again, that's on the major axis. Go down 3, so those are our foci. So the foci look to be at 2, 0. And again, that's just counting spaces. That's all this is. And 2, negative 6. So I found what the center was. I determined what my major axis was, just determining which of these numbers is bigger, because the bigger of these numbers has to be A, which has to be under your major axis. I figured out what A and B were. I found C from the relation, and then I just literally counted boxes. But the most important thing I can tell you with ellipses is to make sure you know what these three things are. I would have those really highlighted in your notes. We covered those on an earlier page. But I would really encourage you to commit those to heart, because those are really the things that are going to help you do these ellipses. Just a quick look at what Desmos would present with us. Very similar stuff. You can see here's our vertices at 2 and 2, like we had mentioned when we did it by hand. Here's our 2, negative 8 for our vertice. Here are our co-vertices. Doesn't have the foci. We know from our algebra that it should be at 2, 0 and 2, negative 6, with our center of 2, negative 3. So a little bit about ellipses. Let us know if you have any questions.